Hello everyone, let's solve MEXT.Math.A 2014 question 1.3, okay? So he's giving you 5 to the 29 power is an integer with places by assuming that log of 2 in the base of 10 is equal to this. So even if you don't know how to answer this, you can like think from the tip that he gave you that it has something to do with logarithmics, right? So look, first let's explain the question. Well, look, if we had like a number, let's say 3, how many integers does he have? How many places does he have? So 1. This is what he's asking you, okay? So if you had like 1, 2, 5, 4, how many integers does this have? What? 1, 2, 3, 4, 5. So it has 5 places, okay? So this is what he's telling you. So now you might think, well, then it's easy. Let's just take 5 to the 29. Well, let's multiply 5 multiplied by 5 29 times, and then we might get something like this, and it goes with a lot of number, and we count them, right? Yeah, but look, you can't do this. 5 to the 29 is very big, and the max uh, is only 1 hour, so it won't be worth it. So we need to use the tip that he gave us. So look, I will be leaving a video in the description that helps you understand the formula I'm going to use, and I'm going to try to explain it. You can use logarithmics to know the number of integers, and when you know the formula, this answer goes like immediately. But look, I will write the formula first, and then I will talk about it. If you don't feel comfortable with the formula yet, watch the video, or even watch it just to be more comfortable. But what it tells you, imagine you have a number n. In our case, just so that you can be go along, n will be 5 to the 29, okay? So imagine a number n. If we want the number of its integers, so the integers of n, and in the video that I'm going to leave in the description, he writes it this way, is the floor function, and I'm going to tell you about the floor function in a second, of log of n in the base 10 plus 1, okay? This one is not inside the log, okay? It's log of n in the base of 10 plus 1. So and now if you like using this formula, the answer goes immediately. But now let's try to explain the formula, and feel free to watch the video. The guy explains better than me, okay? So look, if you have like a number, let's say 1, okay? How many integers does he have? Well, 1, only one place. So what about 2? Well, it also have one integer, okay? 3, one integer. 4, 5, 6, 7, all of them have one integer. And what about 9? One integer. Now 10. Something happened. In 10, we get two integers. And now here I want you to start suspecting. We have 10, something changed while having 10. And the logarithmics that we have is in the base of 10. So something in, so here this is why you think about the logarithmic, okay? So now for 11 it's 2, for 12 it's 2, and there goes on. 20, it's two integers. 30, two integers, and it goes until where? 99, two integers. And then we have 100, three integers. So again, it changed in the next, let's say, 10 power, okay? And imagine what's going to happen. It is going to stay three integers until 999. Three integers. And then what's going to happen? 1,000. with 4 integers. So let's imagine what's happening over here. Okay, so let's say we want this number of integer, the number of integer number uh, of the number 1. We will say that just testing. Okay, let's test it. So log of 1 in the base of 10 is equal to what? Well, it must be equal to 0, right? Because 10 to the 0 power is equal to 1. So, but this is not right. Okay, why is that not right? Because look, we have 1 as a solution. So if we do log of 1 in the base of 10, we will get 0. But our answer is 1. It's not 0. And this is why we are summing over here plus 1. Okay, this is why we do plus 1. Look, log of 10 in the base of 10. What is this equal to? This is equal to 1, right? But look, our number of integers is 2. It's not 1. And this is why we are summing another 1. Because we can find that there is this connection. The first one was 0. But our integers was 1. So this is why in the formula we have log plus 1. Okay? Here, for 100, log of 100 in the base of 10. This is equal to 2, right? Look, 10 to the 2 power is equal to 100, so this is equal to 2. But how many integers do we have? We have 3, so this is why we sum 1. So this is why the formula has a log of n in base of 10, because we are changing our number of integers every time we change 10 numbers, every time we change a power of 10. And we have a plus 1 because to correct our error, let's say over here. And what about the floor function? Well, the floor function, look, if you have a number, let's say a floor function of x, and x is equal to 2.1, the floor function is telling you to go back to the natural number that comes before it. So the floor function of x would be 2, and it doesn't matter if it was 2.8. The floor function of 2.8 is 2. Okay, so you'll always it's like what we do in physics, you will always put it back down. Why is this? Because over here, like the example I was telling you, is always it was when in the powers of 10, but there are numbers between them, right? And these numbers have, when you do their log, they will have, like, for example, the log of 2 in the base of 10, it's 0.3 something. So you need to round it down. Okay, let's say log of 2, it's 0.3, and then you say it's plus 1, right? Because this is our formula. Our formula is telling us you take the log, you add 1, right? So let's do this. Well, log of 2 in the base of 0 is in the base of 10 is 0.3, okay, approximately. And then we add 1, so it will be 1.3. But we don't have 1.3 integers, we have only one integer. And this is why there is the floor function, okay? So that you always know, go back to 1, okay? And so I hope it at least make a little bit sense. I will leave 2 videos to so that you can be more familiar with this formula. So now let's use our formula that I hope you don't just memorize it, because and then you will forget it really fast, maybe even before the exam comes. So now let's use our formula to solve our question. Well, our question was n is 5 to the 29. 5 to the 29. So if we want to know the number of integers, we can do log of 5 to the 29 in the base of 10 plus 1. And remember, we are going to take the floor function, like we are going to take the approximation downwards, okay, to the nearest natural number, not nearest, the natural number that came before it. For example, remember the floor function for 3.9, it's not 4, okay, it's 3, the floor function. It's like you go down, you go to the floor, okay, floor. So just remember this, okay? So how can we solve this? Let's solve it in parts, okay? So log of 5, well, it's to the 29 power, so we are going to use the logarithmic properties. If you have log of a in the base of b to the c power, this is equal to c of log of a to the b power, okay? Just a logarithmic property over here, okay? So let's do it. 29 log of 5 in the base of 10 plus 1, remember, and the floor function, okay? So we don't know the log of 5, but he did tell us the log of 2, right? Log of 2 is equal to 0.301. 0.301. Okay, this is, I wish he would give us just 0.3, but no problem. So just so that we can remember, so we don't know the log of 5, but we know the log of 2. So how can we go on solving this? So 29 log, now 5 is 10 divided by 2. Why did I think of doing this? Well, because logs, when we can use zeros and ones easily, and tens when we are talking about logs, and the 2 is the information that he gave us. So this is why, like, you need to think, we have 5 and we need to, and the only information is log of 2. So how can we connect 5 and 2? Well, 5 is 10 divided by 2. Now here plus 1, and we have the floor function, okay? So 29 log of 10. Let's talk about another property of logarithmic. So log of a divided by c in the base b is equal to log of a base b minus log of c base b. Remember this? If you have something dividing, it goes subtracting, so from logarithm. So 29 log of 10 in the base of 10 minus log of 2 in the base of 10. So there are parentheses over here, plus 1. Remember that this plus 1 was to correct our error when we are doing the logarithmics. So now we have only cool numbers. 29. Let's just sum the. Actually, we can't, right? Yeah, we can't because the 29 is multiplying. So, yeah, sorry. So 29 multiplying by 1, log of 10 in the base of 10 is 1, minus log of 2 in the base of 10 was the information that he gave us, 0 0.301, 0 0.301, and plus 1. Okay, so 1 minus, so this part over here will be 0.6. So the this 1 minus this will be 0 0.699. If you do this, you will get this. Okay, so and you might think like, ah, we need to make this one minus this, and we won't have a calculator. And to be honest, you're right. If someone like have a better answer, you can share with us, because without a calculator this is really, like, it's bad, but doing this would be worse, right? To calculate this would have been much worse. So doing this multiplied by this, which is something that you would have to do without a calculator, I already did this here, so that we don't take much longer than I already did. So it would be this multiplied by this, it would be 20.271 plus 1, and remember the floor function. So we would have the 20 point this plus 1, it would be 21.271 floor function, and this is why the answer is 21. Okay, so I'll see the description, and there will be few videos, not mine videos, from other person explaining this if you didn't understand the formula that I used. Okay, so this is it.